everyone. I wanted to do a quick walkthrough in ArcPro today to try to answer the question of why it's okay to change the projections of vector data, that you don't distort your vector data by doing so, but that you should rarely or never, or at least always, use caution when reprojecting or changing the projection of raster data, because changing the projection of raster data leads to distortion of your data. Why is that? So the reason is because if you recall, vector data are all built on vertices, whether they're points, which are point vertices, lines, which are connections between point vertices, or polygons, which are connections between at least 3 point vertices. In each of those cases, the base unit of vector data is a point. It's a vertex. And a point, if you recall from thinking about maps and things that can be distorted on a map. What can be distorted on a map? Area can be distorted, shape can be distorted, distance can be distorted, direction can be distorted. A point has none of those things. A point has no area, a point has no shape, it has no distance, it has no direction. And so when we change the projection of vector data, whether that's points, lines, or polygons, we can change the projection again and again and again. And if we change it back to where we started, we'll still end up with the same exact thing. So here's an example. I have the towns of Massachusetts as a polygon, and I have a raster data set of topography in this part of Western Massachusetts. I'm just going to turn that off for the moment, and let's just focus on vector data, right? So right now, let's find out what the coordinate system is of my map. Right now I'm in Massachusetts State Plane. That's a conic projection. That's also the native projection of towns poly, my towns in polygon form. Let us do some other state plane, for example. Let's go find, Alaska might be a little too extreme. Arkansas sounds like it might work okay. And you can see in this case, so we're not showing all of the states, but if you imagine, Arkansas is to the south and west of the state of Massachusetts. And so this new projection is better for Arkansas than it is for Massachusetts. Now we're just viewing it differently right now. We haven't actually changed the projection, but we can do that. If we get over to geoprocessing and I use the project tool here, then I can change my town's poly, which says it's this input coordinate system. I'm going to change this to town's poly, say Arkansas. And let's use our projected coordinate systems. That was a state plane projection. I think it was in that. There's lots of things to choose, as always. And I think I chose Arkansas North, but it doesn't matter too much. All right, so I can go ahead and run that. And then I'll get a new data layer of towns poly in this new coordinate system. Okay, so can I verify that? I love that all the colors stay exactly the same. Let's make it a slightly different color. Green. Let's go for nice pink, nice Arkansas pink. Okay, so now I have my Arkansas and my towns. The one thing to notice is that if I zoom way into something that looks like a vertex right here, it's in exactly the same spot in both of these, right? So nothing has changed in that sense. Am I sure that I actually did change the coordinate system? If I look through my layers, now I can see that, yep, my town's poly AR is in my state plane of Arkansas, and my town's poly Massachusetts is in, or well, town's poly with no suffix is in Mass state plane. So then the question is, okay, well, let's then bring it all the way back and use my project tool again. Now I want to use my towns poly, which is in this Arkansas state plane. I want to make this my towns poly for mass and change this back to, luckily, this is handy that it shows me my layers, so I don't have to like dig around for the Massachusetts state plane. So basically what I'm doing is I have started with something that was in Massachusetts state plane. I output a new data set of the same thing in Arkansas state plane. And I took that Arkansas state plane one and put it back in, Massachusetts state plane. So here's our final one. Let's make that one orange. And what you can hopefully see is that when I click on and off, I end up with exactly what I started with, right? So all of those edge points, vertices are in the exact same place. There's no distortion, nothing awry has gone on. I could spend the rest of today projecting, reprojecting basically this data set over and over again. And as long as, then if I eventually went back to Massachusetts state plane, I should end up exactly where I started, no distortion associated with this polygon layer. All right, so let me zoom to Mount Holyoke and turn that guy on. So it's going to be a little bit different when we deal with raster data. Again, going back to things that can be distorted on a map, if you recall, raster data are built on pixels, right? And I can tell already just by zooming in that I'm not in the native coordinate system of my Mount Holyoke topography, DEM, because these pixels do not look square and they look slightly askew kind of thing. So if we're going to reproject a raster data set, whenever we do that, a raster data set is always built on square pixels. And a pixel is always square. That means it always has an area, it always has a shape, a square shape. It always has a distance of the X and the Y of that square. And the squares have a direction, right? So they should be like squared up, excuse the pun, to the North Pole, essentially, or whatever the northern direction is of your data. So let us go to what the original, so Mount Holyoke is actually a geographic coordinate system. If this, just having the datum there is not super illustrative, we can open it and see, okay, this is just a geographic coordinate system. There's no projection layered on top. And it's using these details of the approximation of the Earth as a spheroid. All right, so let me just put us back into the native coordinate system, which is not projected, just a geographic coordinate system for this DEM. Now you can see that these pixels are, if I get to sort of an edge that has a sharper topography, you can see that these pixels are square. So they have shape, area, distance, and direction. Now, if I change the, I can visualize this without changing the coordinate system of the DEM. Let's just visualize it in, let's see, some other projected coordinate system. Let's do one of these world ones, like one that's good for showing the whole world, like a Mallwide one. That's exciting. All right, so that looks not super square, right? So something has changed considerably when we view this topography data in this Mallwide projection, which is good for showing the entire world, not necessarily good for showing Western Massachusetts. Okay, so we can see that these data are not square anymore, that they are not facing a northward, like to the top of the screen direction. So we have distorted the shape in the area. Visually, we haven't actually distorted it yet. We've only visualized it in a way. I'm trying to find one of those edges that's more obvious. Okay, so if we tell GIS that, and the tool is different, it's actually a project raster tool that we want to use. If we say, I want to have my Mount Holyoke DEM, but now I'm going to do it in a Mallwide. That's how you spell it. I'm not sure that it is. projection. And I should be able to find that in the current map because I've already set my, map to be that projection. So it is hopefully seeing this as a world Mallwide, and here's all of the information about it. Now, what GIS is going to do is it's going to take those units that were formerly angular units in decimal degrees, and it's going to convert them into meters. So it's going to make each of these pixels, it's approximating them into a square of 32.79 meters by 32.79 meters down in here in the lower right. In order to get a square, right, GIS has to draw its approximation of a square on top of this basically, I can't remember what those things are called, a skewed rectangle, right? So here's what it did, right? It said, all right, well, you forced me into it. I need to make what is essentially a sideways rectangle into a square. So if these have a slightly different stretch on them, so it's a little bit unfair, but if I scroll into a bit that shows you these pixels, here's what the new squares look like, and you can barely even see them there. Here's what old pixels look like, here's what the new pixels look like, right? So, you're still retaining the high to low of the topography, but you are losing the shape of the original square. So GIS has essentially had to recreate information. And if I click on the value of this pixel, I can see, okay, so that one is 68, meters for the Mount Holyoke, whatever that one is, the Mallwide projection. And if I click on that same one, it might not be the same value. It might be interpolating across multiple values to get that value of 68. So not only has the shape and the area and stuff of these pixels changed, but the actual values associated with those pixels is forced to change as well. In fact, you can see if you look over here on the left that we've lost the sort of minimum 23 meters above sea level, and now it's 24 when we go to Mallwide. Okay, so let us then put this back like we did with the vector data a second ago. I want to take my Mallwide and I want to put this back to GCS. And I want it to be what my original one started out with. Okay, so this is now going to go back to this geographic coordinate size. It is using, there are different resampling techniques. So, this is essentially trying to pull the information from the closest pixel center, but you could also actually, run an interpolation depending on what you are trying to change. All right, so let me see what happens if we run that. Cell size looks a little weird to me. So ideally, what we would get, or what we might hope to get if we didn't know better, is the exact same data that we started with. And let's just so that we're not looking at this in this crazy projection, I'm going to put it back to that geographic coordinate system, which is what my original DEM is in, and my new DEM that went over to Mallwide and came back to this same projection is in. Okay, so let us find an edge where we can hopefully see what's going on with some pixels. All right, so here is my new one, and there is my old one, right? So I've actually changed the pixel size too. I could have set that so that it went back to the same pixel size. But one important piece in here is that you can see that they are not perfectly aligned, right? Like if you sort of focus right here on the edge of those two pixels, I'm trying to do it too and click at the same time, you can see that it moves. It's not in the same place. And the pixel values are not necessarily the same. So if I click on that one, I might get 85. That was over here. I have to put my finger on the screen so I can get back to the other one. Now I've got 89 as a value on there. So all of this is just a demonstration to illustrate why it's totally fine to change the projection of your vector data files. It is not a good idea generally to change the coordinate system or the projection of your raster data, because anytime you do that, you are going to distort your data, change your data, and that is just generally not good data management practice. Better to just go with the original in whatever its coordinate system is, unless there's a really, really good reason to change that. So thanks for listening.